This video is about configuring and using a bath interferometer. Links to other bath videos are in the description below or at gr5.org/bath. Also at that webpage, I have information on how to build your own bath for around $100. I'm not a mirror stand expert, but the bath and DFT fringe together can measure exactly what errors are caused by your mirror stand or errors from the bath itself. So that's a topic for other videos about DFT fringe. I've marked the top of my mirror. I don't know if you can see it with a mark. So I can rotate the mirror and know how much I've rotated it. We're going to start with the marks. I'm going to start with the mark straight up. Now the bath. So here's the laser. Now always treat your bath like it's treat your laser like it could blind you, because maybe it will. Now this is a 5 milliwatt red laser. Supposedly it can't blind me, but I'm not going to find out. So I like to keep it a little bit lower. That's why we're looking down on it from my head height, so that it's less likely to flash into my eyes when I'm walking around and it's on. So I have this nice blue part here to hold this paper, which I'll demonstrate later. There's the two beams coming out. So if you have a laser like this where you can see the circuit board, you want to make it vertical. You can focus these lasers. They come in, there's two pieces that screw together, and as you change the tightness, it changes the focus. There's a drop of glue in there that holds it together once it's focused. They put a drop of glue in the factory. I, of course, took it apart to see what was going on, cleaned it, screwed it back on, focused it, and re-glued it with a drop of glue. So your bath should be mounted. So the lasers are pointing this way, the two beams are pointing this way, and the camera is going to be just this side of the bath. So that's why the bath is mounted right up against this edge, so that the camera lens can be really close to the bath. If the bath was facing the other way and the camera hit this, you'd have this huge gap between the bath and the camera lens. You need to get the camera lens close, or you get vignetting, unless you have a really fancy lens like I do, which I'll show you later. So that's the direction towards the mirror under test in this case. And so this is going to be the Z adjustment, and I really like having the Z adjustment away from the mirror under test. And then this would be the X adjustment, and so I'm going to center these right now. Actually, that's pretty well centered. That's pretty well centered. And then I'm going to center the Z so that I have plenty of room to go up or down. It's good to have this circuit board vertical, roughly, which means these dashes coming out are horizontal. In fact, it's probably more important to get those horizontal than to get this vertical. You want the reference beam and the test beam to be similar brightness, and I found that if they look like a horizontal dash, you get a good I-gram, and you'll get a fainter test beam. And if you rotate the laser so you have a vertical dash, then you get a reference beam that's too bright, and it's harder to see the edges of the interferogram. This has to do with the polarization of the laser light. Inserting a polarization filter between the laser and the splitter can also help, but make the results dimmer. Or use a polarization filter on the camera. That can help a little, but I find just rotating the laser is good enough. So I've placed this so that the beam is going roughly through the center of the cube, the splitter cube. A lot of people want to move this more over to the left, so it's at the pointing off near this corner of the cube. If you go close to this corner to the cube and you place this second mirror up closer to where the laser beam comes out, you can have the two beams very close together. 6 millimeters apart is reasonable. As you can see here, I have them a lot more than 6 millimeters apart. I'm guessing about 10 here. There's a worksheet in DFT Fringe, which maybe I'll cut in and demonstrate now in the video, that shows you how much this is going to contribute to astigmatism of your mirror. Don't worry too much about astigmatism right now, because you can remove any astigmatism created by the bath itself by using DFT Fringe. In effect, you take at least one other set of measurements with the mirror rotated 90 degrees. But do be aware that if you change the distance between the beams, the astigmatism will change. So if you change this distance, you should start over with a fresh set of measurements. Start off putting the laser through the center of the splitter, just so you can start to learn how to use your bath. So I'm going to move this paper, well, I'm going to take the paper away. And I've turned it so it's pointing at a piece of white paper. This room is great because I can turn off this light and I still have light coming from the next room. It's really great to have a room where you can adjust the light constantly. Ideally, you want a dimmer switch near your bath where you can reach and change the brightness of the light in the room. Also, it's really good to have a concrete floor. I've tried to do this on wood floors, and it's a lot more work in the long run because you're going to need to take hundreds of photos, and to make it easy to process the data, you want all the photos coming out identically. Alright, so let me show you how to set up the bath. The first thing is you want to put the distance between the mirror and the bath equal to about double your focal length. Your focal length. So the double that is what's called the center of curvature or radius of curvature. And so if you know what that is, you should measure with a tape measure to get the distance from the mirror to the bath within a few inches of the correct value. And I'll show you how to get it even more accurate later, but first you want to get it close. So we're going to start collimating things. So if you can see that the two beams are not on top of each other, I'm going to start moving this mirror here. And when I move it, one of the dots moves. So I'm going to collimate them, which means have them go to the same point. And I guess in theory I could try to have the movable one about 10 millimeters to the right, but we don't have to get that perfect. It's not perfect, but it's fine. And before I did that, I pushed this diverging lens out of the way. The diverging lens is in here. So now I'm going to insert this diverging lens into the path. So now that I got these two beams pretty close, I want to pull up this lens in my left hand here. And there you can see it's taking that single beam, diverging it. This is our diverged beam. And I want to get it centered. I want this big thing centered on that one dot, red dot. So I'm sliding the tool up and down a little bit. And then I can hinge it left, up, right, down, left a little bit. Tightening it. Okay. That's probably close enough. And the reason I do this is so that I know the laser is going through near the center of the lens. So because the two beams are collimated, in other words, pointing to the same dot on the paper in front of us, now I can put the lens in place, and if the lens is if we're going through the top part of the lens, it won't be lined up. If we're going through the center of the lens, it should be lined up nicely, right about there. And that's good. We want to use roughly the center of the lens. And you can see my beam is roughly horizontal. It's not perfect, but it's good enough, I think. Okay, so everything's collimated. So now I'm going to rotate this over to the telescope mirror and center that dot there on the telescope mirror, and you can see that the telescope mirror has good coverage. You need the whole mirror covered by that diverged laser light. And there's two beams coming out of this. There's the test beam and the reference beam coming off this flat mirror. So I'm going to insert this piece of paper and block just the reference beam. So you can see the reference beam is coming through the paper there. But the test beam is still illuminating the mirror nicely. Now that test beam is coming back, and I already see it. It's right here on my hand. So, and it's coming to a focus about here, and it needs to be coming to a focus near the test stand. So I can fortunately just kind of move this mirror You might not be able to, so in this case you might have to move the tripod. But I'm going to move that closer. And now I can move, I'm going to move, it's hitting part of the paper here. And I need to move the tripod back. I can see it's focusing about 10 inches back, so I need to move it halfway there, about 5 inches back. And I don't need to go up or down or left or right. I might go down slightly so that it's always over this piece of paper here. So move the tripod back about 5 inches. So much better. Now it's focusing about an inch behind the cube. I need to move the tripod this way to get the light to come this way, and only halfway. So I'm going to go about an inch that way and maybe less than an inch back. So I'm going to go a little bit of adjustment. Oh, this is getting really good. So that's pretty close. I'd say it's in focus there, which is right about over the back of the cube. That's what I want. I want this dot coming back from the mirror, right, which is big here and gets smaller and smaller and smaller. I want it to be smallest right about here, which is right over my splitter. The rear of the splitter is pretty close to where you want it. I don't know if you can see that, because you just see a big fuzz on my finger I see in the camera, but I see a little tiny dot that's extra bright. Okay, I dimmed the laser a little and I dimmed the camera a little so you can see the dot better. So it's bigger here, gets smaller to a point about here, starts getting bigger again. So now you can see in the camera better that it gets to a pretty small point right over the back of this splitter cube. Okay, now the next step, because it's going over the top of my paper, is to bring this up. So I'm going to loosen this and slide the whole tripod head up. And I want these two dots that are getting close together to be right touching. I could move the leg a little, but it's easier to just turn this knob here. Turn, 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 clockwise, clockwise, clockwise. And now actually this is a good time to make sure the head's nice and tight. We tighten everything. Okay, good, the head's tighter now. Clockwise, clockwise, clockwise. I want that dot in the center of that line. Okay, beautiful. Now we're ready to look at some I-grams. So I'm going to slide this over to turn that whole thing on. And back here, behind me, we should be getting, behind the whole thing, we should be getting a nice I-gram. Let me get a piece of paper. Let me turn off the light. Ah, horrible. What's the problem? The problem is I bumped something and the reference beam is no longer on the mirror. So I'm going to grab the tripod with the interferometer and point the reference beam back at the mirror. Okay. And everything is still good. Good. Okay, but the two beams are no longer, where's the returning beam? It's back here. I'm going to turn this clockwise some more, clockwise, 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 until the two beams are on top of each other. Slide this back and look back here. Oh, this is great. So you can see this smaller circle here, and then you can see this laser thing here, and you can see that two dots up there. We're going to ignore these two dots up at the top. So we want this big circle. That's the actual mirror. If I put my hand in front of the mirror somewhat, you can see my hand. I'm reaching as close to the mirror as I can reach. That's the mirror. That circle is the roundness of the mirror. If it was a square mirror, you'd see a square. We want to get that mirror up into the reference beam. The reference beam is this part here now. It looks just like the test beam, but it's not. So now I'm going to turn the vertical thing until that's pretty well centered. Let's turn the horizontal. a little more towards the center, and there you can start to see some of the, I don't know if you can see it. I bet you can. Yeah. There we have our first igram on a sheet of paper, not yet in the camera. Now I want to try to, and I don't think this is necessary, but I want to try to focus this. I want to focus the Z. I want to turn the Z knob. The Z knob is back here on the XYZ. Because when I got that focus just at the back of the splitter, I did not get it perfect. So I'm going to try turning the Z clockwise, and we'll see if this pattern gets better or worse. I'm going to move this camera closer so you can see better. Okay, so I turn the brightness of the laser back up to where I usually keep it, which is full brightness. So now I'm going to turn the Z screw. I'm going to try clockwise. So the goal is to get, instead of the 30 or so bullseye circles, I want to get like 1. So I'm going to try clockwise. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I think it's getting worse. I'm going to try counterclockwise. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 turns. 1, 2, 3, 4, 5, 6. Yeah, I think it's getting better. 7, 8, 9, 10. Now I need to center the Z. Oh yeah, it's getting better. So counterclockwise is better. So 1, 2, 3, 4, 5 counterclockwise. We got to recenter to the Z to see how we're doing. I turned it the wrong way, of course. Let's move the X knob a little bit. Nice. So we're getting good. So which way I was going? Counterclockwise, I think. 1. We're gonna go like I'll try like 4 more. 1, 2, 3. Well, maybe 3. And this is probably good enough. It's fun to get it perfect. Yeah, it's getting pretty good. That's good enough. Now I think it's time to put the camera, hook up the camera. Okay, so I got the camera on the tripod. I happen to be blessed with an amazing lens here. It's an f1.8, 85 millimeter. It's an f1.85 millimeter lens. I can actually put it this far back. You might have to put your lens right up close to the splitter. And this mirror is around f5 or 6, I forget. If you had an f3 mirror, you would have to get the camera closer because the beam coming out of here gets wide faster for an f3 than for an f6. And so the lower the f number, of course, the harder it is to make the mirror, the harder it is to test the mirror, harder it is to do everything. But it's not too bad. So I put it on manual focus, I put it on manual exposure. The first thing I want to do is focus on the mirror. So I'm going to turn the camera on, put it in live view mode, and I already have some an igram. I haven't even lined it up yet. So I'm going to push the camera over to the side a bit and aim it at that. I'm going to have to change the ISO up to 2200. And I am way out of focus. So I'm going to turn this focus knob, and then I'm going to zoom in and look at the edge of the mirror. And then focus it as perfectly as possible. How about there? Okay, and then I'm going to put the tripod back where it was. Let's zoom back out. And I need to go a little to the right, I think. If I push, yeah, I want to go a little to the right. Hard to do with one hand. Oh my god, I got it already. I need to change the ISO here. So I was at ISO 2200 just now. I'm going to change it down to ISO 100. Need 2 hands to do that. Okay, ISO 100, and then I can change the shutter speed We are at 500th of a second. So if I took the picture like this, it would be too overexposed, and the DFT will not come out very well. So I want to get this up. Plus, it's nice to have a very fast shutter speed. 500. Yeah, so even here, about 2000 is good. Oh, I also have, I haven't touched this yet, I also have a polarizing filter that I can rotate. So let's see what happens when I rotate it here. So I can turn it and they both get dark and then they come back on again. So if I go clockwise, the mirror comes on first and then the background noise. If I go counterclockwise, the background noise comes on a little before. So I'm going to go clockwise. And I could leave it right there. And I bet I would get better results than I've been getting. But I've been purposely showing the background. Maybe I'll just do some without the background. So there, now we just have the fringes and not the background noise. And this will probably make, I haven't tried it yet, I'm still learning, but this will probably make DFT fringe happier and able to find the edge of my fringes better. This is a little dark. I am going to adjust the shutter speed down to 1000, I guess. Yeah, it looks overexposed in your view, but it looks really good on the camera. It's really hard to film this with these auto adjusting things. Okay, so are we ready to take a picture? Not really. We want to get more fringes. So I'm going to turn the fringes a little bit. I'm turning the X. I want to get more fringes. Wow, we have some ugly dirt on there. Okay, that's good. We're ready to take pictures. So I'm going to hook up the... Okay, so I got my cable release hooked up. I push this button, takes a picture. So I'm going to zoom in on this a little with my, just to view it closer. You can see we've got nice edges. That's probably, what do you think? How many fringes is that? 1, 2, 3, 4, 5, 6, 7, that's about 22. You can get up to 60. The fan. We need to turn on the fan. Okay, do you see something different? That's because the fan's on. You might think this looks worse, but it's better. So really, I found I have to run the fan for a good 20 minutes to get good astigmatism-free pictures, which seems bizarre. But the floor is about 3 degrees cooler than the ceiling, and so you get stratification where the cold air is down low, medium air is in the middle, the hot air is up top, and that's going to bend the light like this, the laser light. And that's going to also give you some astigmatism. It's only a tiny bend, I'm exaggerating, but it's going to act like a prism, where the bottom of the prism is wider and the top of the prism is a point up across here, and it bends the light down. So, yes, it looks horrible, but we have a shutter exposure of 1,000th of a second, and that's good enough to freeze this noise. So we can actually take pictures while it's doing this. But I found that if I don't wait 20 minutes, they will not be good results. I really find I have to run the fan for a while. So ideally I would go away for 20 minutes and come back. And you'd see the same thing. You'd see this jiggling pattern. But you'll get better results when you're in DFT fringe. So, yeah, so that's only about 22 fringe lines. I can turn this some more and get more fringe lines. I can usually get up to about 100. I usually go for, Dale recommends 60 at least. So that's a good amount there. It doesn't look so great at the top. Yeah, that doesn't look so great. So I'm going to turn the Z-screw here a little bit. Try to get the tops. Yeah, the top looks much better now. Actually, that's a good reason to show the background noise. You know, in other words, turn the polarizing filter a little bit so you can see the background noise, the background pattern, the reference beam. You can see a little bit of reference beam in here. Anyway, that looks very good. So let's take some pictures, even though we haven't let the fan run for 20 minutes now. So I'm stepping back away from everything so my feet don't affect things. I didn't demonstrate this, but if you experiment and walk around even a concrete floor, you'll see the fringes bounce around. And I want to be able to take a whole bunch of pictures without moving this camera, without touching this camera ever for a whole bunch of pictures, and that way the placement of where the mirror is on the film, so to speak, on the image, doesn't move. If I just touch this camera a little bit, the tripod may move a little bit, and the camera, the position of the mirror may move, and that may make it a lot harder to do batch processing in DFT Fringe. And I want to do, 100 pictures at a time or 30 pictures at a time, not one picture at a time and then have to adjust. Well, you'll see later in DFT Fringe. So I step back a bit. I'm going to take a few pictures. Ideally, you probably want to do maybe 3 seconds in between pictures. If you want to do a really good job, you probably want to take at least 50 pictures at this point. I find that 10 good pictures is probably enough. And now, carefully, without touching the camera, I can't even zoom in, I'm going to turn the X knob. There's back where the X is kind of centered, and I'm going to go the other side and do 4 different sides. So I'm going to keep taking pictures. Hopefully these will come out just as good as the hopefully these will come out very good, and so on. So I would do about 10 or 20 in this position, and then I would mess with the Z knob. So Dale asked me to mention that he likes to get pictures of fringes at 4 different angles, or tilts, as shown here. Horizontal, or roughly horizontal fringes, vertical, and 2 more angles in between at 45-degree tilted fringes. To do this, you have to move the X and Y knobs. You'll figure it out. It's pretty straightforward. What you're doing when you are moving these knobs is effectively changing the tilt of the mirror with reference to the bath interferometer. The tilt is what creates all those somewhat parallel fringes. I still have not touched the camera, so I should be able to combine all of these pictures into one batch run. And so on. So take 10 pictures here, and then move the Z one more time on the other side of the center, and take another 10 pictures. And that's pretty much it. And now we have to go to DFT Fringe.